So I'm hoping you took a few moments to actually look at the previous slide and to appreciate the wonderfulness of the law of cosines. Although it may appear ferocious at first, it's basically just the Pythagorean theorem, with a few adjustments. For instance, if we are given triangle ABC with its opposite sides labeled in lowercase letters, and we're asked to find the length of side C. So the law of cosines is going to start out C squared equals A squared plus B squared minus 2 times A times B times the cosine of angle C. Side C is not trying to be anybody's hypotenuse. It's not even trying to be the longest side. It's simply opposite angle C. And that's a key point. One end of the law of cosines has got to have the side. The other end of the law of cosines, the equation has to have the opposite angle. And we'll be able to use the equation to find either one. If we want to find the missing side, we have to know the opposite angle and the lengths of the other two sides. If we want to find the measure of angle C, we have to know its opposite side and the lengths of the other two sides. But the angle and its opposite side have to be at opposite ends of the equation. If we are asked instead to find the measure of angle A, well, that means the equation is going to have to end with angle A, and it's going to have to start with side A. So it'll be A squared is going to equal the sum of the squares on the other two sides minus 2 times B times C times the cosine of angle A. So whatever we're looking for, that's what determines the ends of the equation. The other parts, the other two sides, fill in the middle. Let's look at a few examples. So example 1, they want us to solve the triangle, which you know is going to be work because they want to know all 6 parts. So first, sketch the thing. So angle C measures 60 degrees. This sort of looks like a 60-degree angle. I'm going to call this angle C. Side A is longer than side B. So I'm going to put side A here, which means this has got to be angle A. This is side C. And if I make this side B, then this has got to be angle B. We can also arrange it in a table, sort of. So we know the measure of angle C. We know the length of side B and the length of side A. I got 3 missing parts. Now for the law of sines, we had to know an angle and its opposite side. Well, we know an angle, but we don't know its opposite side. We got 2 sides, but we don't know their opposite angles. So in this situation where we have side angle side angle side will be a unique triangle. You remember from the laws of congruence, this was one of the congruence criteria. There's only going to be one solution. And that's one of the wonderful things about the law of cosines. No ambiguities. Whatever answer we get, even if it gets messy in the middle, only one answer. So let's try the law of sines. We do have angle C. So if we find the side opposite, then we'll know all the sides. So we could find side C by taking A squared plus B squared minus 2 times A times B times the cosine of angle C. And then fill in the parts we know. So we know that this is going to be 8 squared plus 5 squared minus 2 times 8 times 5 times the cosine of 60 degrees. So a lot of this you can put in the calculator, especially if you write the formula right. You could literally just put all of this in the calculator if you have a direct entry. If you have indirect entry or reverse entry, you will have to put it in writing backwards. I'm going to go through a few of the steps just because I want to point out where people make mistakes. So c squared is going to equal 89 minus 80 times the cosine of 60 degrees. And a big temptation, this is the most common mistake people make. Your brain sees 89 minus 80 and it wants to write down 9 times the cosine of 60 degrees. This does not equal 9 times the cosine of 60 degrees. Because this is all one big term here. 80 times the cosine of 60 degrees. That is all one single term. So that's how we're going to have to enter it into the calculator. For a scientific calculator, you can just put it in directly. Make sure it's in degree mode. 89 minus 80 times cosine of 60 degrees. And it tells us the answer is 49. So if the answer is 49, that doesn't mean side C is 49. C squared is 49, which means that C is going to equal 7. So we know side C, but this said solve the triangle. So we still need to find the two missing angles. We have an angle now and the length of its opposite side. We can go ahead and use the law of sines to complete the problem. And because this was side angle side to begin with, we will not have to worry about the possible ambiguity. Oh my, so now find the either angle A or angle B, it doesn't matter. I'm going to choose angle A, that the sine of angle A over its opposite side has to equal the sine of 60 degrees over its opposite side. Then multiplying both sides by 8. And we can put all of this in the calculator at once. 8 times, unless you're doing the in reverse entry, and then you should try doing it backwards. So I can just put in the sine of 60 degrees times 8 divided by 7. And it gives me that lovely decimal. I really don't want that lovely decimal. I don't want to know what the sine of angle A is. I want to know what angle A is. So instead of, actually we don't have to copy all of this down, I'm just doing it. We need to find the inverse sine. And on these scientific calculators, we can do inverse sine by doing second sine, and then I'm going to ask it to find the sine of this decimal, so I'm going to type second and the negative key. Because down here over the negative key, it says I'll do whatever you want to the answer that's on the screen. So typing in second sign, second answer, and it says that's 81.8 degrees. So the measure of angle A is 81.8 degrees. And we can then, of course, go find the measure of angle B, because we know that all three of these have to add up to 180, and the measure of angle B turns out to be 38.3 degrees. Sorry, 38.2 degrees. So yes, that was a long problem, especially for example 1. But the cosine part of it wasn't that hard. So let's try another example. And in this case, they only want us to find the measure of angle Z. We do not have to find the whole triangle. Once again, little sketch here. Well, they didn't tell us the measure of any angles. I don't see degrees on any of these. And we just have 3 sides. So I'm going to make this side be Z, because that looks like it's the longest. This side be Y. And this side X is the shortest. So this would have to be angle Z, angle X, angle Y. And all they want is angle Z. So we know what the lengths of the 3 sides are. We do not know any of the angles. And for the law of sines to work, we have to have an angle and its opposite side. This is a side, side, side. That's the information we're given. That is a unique configuration. We will not have to worry about any ambiguities. And with the law of cosines, we won't. We can find the measure of angle Z here if we know its opposite side and the lengths of the other 2 sides, which we do. So we're going to end our equation with angle Z, which means we're going to start our equation with side Z, that Z squared is going to equal X squared plus Y squared minus 2 times X times Y times the cosine of angle Z. And then we substitute in all the numbers. So 12 squared is going to equal 10 squared plus 11 squared minus 2 times 10 times 11 times the cosine of angle Z. So there's only one thing missing in the equation. That's who angle Z is. You could do most of this in the calculator. I want to write out some of the steps here. And then 2 times 11 is 22 times 10. So you could put in the calculator 144 minus 100 minus 121, and then stop there. Do not add 220. But if you want your calculator to do as much thinking for you as possible, you could go ahead and do that. Oops, this side comes out to be negative 77. Do not add 220 to both sides. This is negative 220 times the cosine of angle Z. So we have negative 77 divided by negative 220 is going to tell us the cosine of angle Z. And then to find out who angle Z is, we could take the inverse cosine of negative 77 divided by negative 220. Let me clear out the last stuff. So second cosine, negative 77 divided by negative 220. And it's saying that the angle is 69.5 degrees. And there we have it. That's all we're asked for. That's all we have to give. If they had wanted us to complete the triangle, we would have to go back, use the law of sines probably, to find out the measures of the other two triangles. So if you would now please make sure you printed out the 2 sheets of sample problems and the two sheets of word problems. And they're not all solid sheets. It just happened to be on, each of them has 2 pieces of paper.